thing on? Yes, it's on. Okay. I have a joke to tell you. It's about UDP, but you might not get it. I got to warm up a little bit. An IPv4 packet address walks into a bar, tells the bartender, "Give me a cider, I'm exhausted." An IPv6 packet or address walks into the bar, no one wants to talk to them. Hello, everyone. My name's Marino Wijay. I am glad to be here at DevOps Days Minneapolis. It is an honor. Honestly, I've heard that this is one of the best DevOps days out there, and so I'm excited to be here. How are you all doing? It's day 2. I'm sure you've got your opportunities to hear some great talks, and then not only that, you had that chance to hear some open spaces. It was something about service mesh yesterday, and we had some really good conversations. I will say this is not a service mesh conversation, although I have some controversial topics I have to bring up. So first and foremost, I am Marino Wijay. I'm a developer advocate at Solo.io. We solve application networking problems for microservices and containers. You can find me on Twitter. You can email me if you want, although I never check my email. You can find me on LinkedIn, and if you want, I stream on Twitch every Friday. I skipped last Friday. I'll probably do this Friday, and I just talk about a variety of tech topics. All right. Service mesh is a VPN. So this is kind of controversial for a lot of folks. Maybe not for you in the audience, but there's a bit of history here, and I actually want to talk about how we got here, how we got to the fact that service mesh can be conceived as or perceived as a VPN. I'm a network engineer, so when I look at patterns, that's what I'm looking for. I'm looking for cyclical patterns, and service mesh happens to be one of those. The other thing I have to say is your infrastructure needs to die. This is actually a presentation that was delivered by Timothy Mamo at DevOps Days Seattle. And his talk was really about infrastructure going down the path of being distributed, immutable, and ephemeral. And networking needs to die by the same sword. So networking also needs to become distributed, immutable, and ephemeral as well. So we'll get into a little bit of that. So for me, it started off with, 15, maybe even more than that, 20 years ago. I had this desktop in my office. Actually, not even my office, my little room that I was sleeping in. And I just wanted to have access to a computer so I can get on the internet. And I did not know how to wire anything. And so wireless, 802.11b, was the standard at the time. So I went to the first computer shop that I could find, picked up a PCIe card, picked up a wireless router, set it all up, and then all of a sudden that word started spreading out throughout my family and friends, and everyone else wanted their wireless network set up. So that's kind of how I got into that whole phase. But what was interesting was it wasn't about just plugging and praying and hoping that those packets would move around. There was so much more to it. I just didn't know, right? I was trying to figure it out, and I needed a way to kind of get into that whole space. And so I started from the bottom, and now we are here at the OSI layer. And so I want you to imagine an OSI layer. Actually, I won't do that to y'all. I actually have one. But the idea here is that I started right at the very bottom in the sense that I started working with physical devices and cables and whatnot. And what ended up happening was, for me, electrical signals was cool and all, but what was the intelligence behind that? How did I figure out how these things were communicating? And so when I was working at a particular company, I was doing a whole bunch of network switch changeovers. I didn't really know what I was doing. But my supervisor at the time told me to really dig into what was going on here, understand how those packets were being learned and shifted throughout that network. And it really started off with me going through a certification path. But I'll talk about that in a second. What I'm really here to emphasize with this particular OSI model is that as we climb up that stack, we gain more and more intelligence in how we can make our decisions for how packets move around, how we communicate with each other, how we form our networks. And so 20 years ago, we had this concept of I'm going to log into a device, and I'm going to configure it, and I'm going to do this again 1,000 times over. Today, that's changed. We use one single line of or one set of configurations, and we can apply to a variety of devices using automation tools. And I kind of wish that was there when I was doing networking years ago. So for me, it started off with that chasing the whole certification dragon to really understand technologies around networking. So to get better, what I did was I chased after certifications, and quite honestly, it's very exhausting. There's a lot of network certifications out there. I'm not going to describe what they actually are. But one of the things that it really taught me to do was how to become an expert in that space. It never really made me an expert, but it just showed me that there are so many different resources I can dig into if I ever had a networking question, and I could go find that out and share it with whoever I needed to, and solve my problem pretty easily. But it didn't stop there, because the whole certification game is a never-changing, an ever-continuing game is what I mean to say. It just keeps going. You can't stop because technology changes, as we know. The technology frameworks that we work in also change as well, and so you constantly find yourself in this vicious cycle of renewal and renewing your certifications, and I just gave up. But along that journey, that actually led me down the path of having to work from working with a few packets to actually configuring and supporting campus networks, to setting up data center networks, and then even cloud networks, but also storage area networks. Like, how many of you have played with jumbo frames today and had to configure that for your iSCSI switching and FCOE? Ooh, FCOE, what a dirty word. But anyways, it really gave me this context and this perspective of the fact that there are so many facets of networking, but the biggest challenge is, why is my thing not working? The biggest challenge is this: there was just so much to worry about. You walked into a data center and there was Cat5 spaghetti all over, so now you're spending time labeling and cabling everything all over again. You have unpatched firewalls because someone decided, hey, if I load up this firmware into this firewall, it's probably going to break all my ACLs. The other thing too is my config files for all my iOS devices are all over the place. Some are on my laptop, some are in some server somewhere else, sitting in someone's basement or whatever that might be. And then you have problems like incorrect fiber channel zoning, and then someone decides, hey, RIP is better than BGP. And then you decide, hey, let's just take on this technical debt and move on to SDN. For those that don't know what SDN, software-defined networking, it was just a way to create networks on top of networks in a very logical sense. So now we are at this phase where we're trying to automate it all. Let's automate the network, let's automate the VLANs, let's automate whatever we can think of. And that paved the way for consistent configuration, removing errors from how we configure our devices, and also creating this very interesting approach to iteration. Like we talked about iterating together earlier on, and quite honestly, I kind of wish I was collaborating with other network engineers years ago to make better configurations for our devices. Unfortunately, we didn't have Git back then. What did we have? Just our laptops and text files. So the automation piece became very critical to us because it was removing all the unnecessary toil that we would have to worry about inside of a data center network, inside of a wireless network, whatever it might be. But then that also paved the way for this concept of net DevOps, because Python was allowing us to automate our networks very efficiently. There was an individual by the name of Kirk Byers who started emailing me, and probably a whole bunch of other people. I was probably registered to his mailing list. And he's like, hey, we have a Python for network engineers automation course. And I thought I could check that out. It's like every other Udemy course that I've ever bought. I buy all these courses, I probably go 1-2 lessons in, and then I just park it. So I'm sure y'all are kind of feeling the same way about those Udemy courses that you have stacked up. But that's what it came down to for me. Like, I started to realize, okay, there is Python that is automating a network configurations, doing things like reviewing configurations. Not only that, like making automated changes through network devices. Hey, I want to change all these interfaces to align to this VLAN. I don't want to log into every device. Let's automate it. And that's where we came to. But not only that, there's also Ansible, so you could use playbooks to automate your networking as well. And then there were systems like Napalm and Nornir that came out to basically create this abstraction layer to allow you to configure any kind of network device, Cisco, Juniper, whatever vendor you can think of. And what that meant was, as long as they served up an API that we can interact with, we can configure it pretty easily. So that actually brought up an interesting challenge and then a set of solutions with that. So how many of you have actually configured an IPsec tunnel before? How many of you have actually seen traffic pass that IPsec tunnel? Right. OK, so I've been there. I fat-fingered like a passphrase or a certificate or something like that, and my tunnel never comes online. But fast forward to, let's say, 2016, 2017, there was this phenomenon going on around SD-WAN, which was effectively just automating the creation of VPN tunnels for a variety of sites. And what was really interesting about that is it took all of that automation that I was just talking about beforehand and just masked it. It masked it because all of these automation patterns we would want to achieve for networking were just codified. They were hard-coded into an SD-WAN system. So now you would deploy devices everywhere you'd want, and then all of a sudden you have connectivity everywhere. But that was a phase. That was a very short-lived phase because, quite honestly, everyone got bored of SD-WAN, and we needed to solve better problems. And that kind of reinforced the fact that, OK, technologies like Git were really important back 10, 15 years ago, and they didn't exist. They weren't around because if I had the access to Git to be able to upload my configurations and then allow others to interact and make their changes and suggestions, do the whole fork and whatnot, and even like create your own branch. But if we were able to do that back then, I think we would have made strides in the networking world. But we kind of fell behind. We kind of delayed our own innovations in the networking space. And that was interesting. So what ended up happening? Kubernetes entered the chat. So quite honestly, like containers in Kubernetes, for many of you that have worked with it, know that it's been around for a very, very, very long time in various different forms. Kubernetes itself, I think, 7, 8 years now it's been around. But because of this distributed compute system that became available, that had to change the paradigm, that had to change the networking paradigm altogether, primarily because the models of networking at that time did not support what Kubernetes needed to do. And then what started happening? Networking namespaces became a critical concept. We started building our container networking interfaces, but not from the lens of a network engineer, from the lens of a DevOps engineer. Someone who cared about applications and how they were broken down into microservices, but also needed to communicate, but also realized these little microservices are immutable and ephemeral at all times. And because of that, the same networking paradigms that we were so used to, those concepts of, hey, I have an IP here, I always need to be able to route it, that's changed, that's gone in this world. And that's critical because today, if I were to configure my networking, yeah, I could simplify my physical layer, but where I get all my intelligence, where I get all that cool connectivity and that ability to route very intelligently, it actually lives in YAML. So, oops, I went back. So now we've actually created even more technical debt because guess what? All of the stuff that we built on top of is still there. What does that mean for us? Well, the world of microservices and Kubernetes allows us to, kind of forget about that stuff. We can move away from it. We can almost say, hey, see you later, unplug it someday, and hope for the best. And that's just because of other technologies like API gateways and service mesh technologies. Again, this is not a service mesh conversation. But the fundamental thing here, though, is that service mesh created a layer, and I'm going to talk about that in a second. It created a layer that pretty much mimicked the original networking stack. We'll talk about that in a second. But what I wanted to point out is like when we as network engineers are looking for familiarity, right? We're so familiar with our routes and how packets move around the network. We're so familiar with Wireshark and TCP dump because it tells us where our packets are flowing from point A to point B and the ports that are being accessed on. But not only that, like we can also use tools like Kiali and Jaeger to identify our HTTP request all the way through from the requester all the way to the responder. And when you marry these two concepts together, when you actually look at them side by side, they look the same. So for a network engineer, if you were to go run Istio CTL proxy config route, with the additional flags and specific details, you're going to have a table that gives you routing information to your endpoints. What does show IP route do? the exact same thing. It's just operating at a different layer. And so for a network engineer out there, you want to consider, okay, how do I take my existing network engineering skills and bring them into the world of DevOps? Well, here's how we start, right? We start looking at the patterns, right? We know that packets are moving around, but we also have to realize that we have to detach ourselves from this idea that IPs will always stay the same. And because of that, there is also a bit of a learning curve for network engineers. And I'll talk a little bit about that shortly as well. But this also has resulted in this fact that now when you look at all your YAML configurations, when you're trying to configure your networking, it's actually going to be in YAML. Literally, when I look at a Kubernetes cluster today, and if I want services to communicate with each other, what am I doing? YAML, right? When I want to create a policy to say service A can't talk to service B, YAML. And so for a network engineer, think for a second here. You've been playing with configurations all this time. Looking at a YAML configuration should be no different, because all it's really doing for you is telling you, or actually the other way around, you're telling it, hey, this is what I want my network to look like, a desired state network. Obviously, you're a network engineer, you're going to have to go learn a little bit about YAML. But the idea is that you're sticking your your network configuration inside of YAML. Now, what are you going to find? You're going to find things like BGP configuration. You're going to find things like layer 7 destinations. You're going to find even quality of service configurations in your YAML. And so that might be scary, but quite honestly, it's the right approach. I mean, I'm not saying YAML is the best language out there, but it's the love language of networking. So I say that all to say that this talk was never about service mesh, because Keith Maddox already covered that for us yesterday. He did a great talk. Go watch the recording if you get a chance. But through my lens, as a former network engineer trying to become a developer and acting as a developer advocate today, we've actually gone full circle. And what that means is 20 years ago when I tried to move packets around, yeah, it worked. It took a lot more work to get there. Today I do the exact same thing, and it takes a lot less effort to kind of move those packets around. It takes a lot less effort to provide connectivity from me to you, from me to someone else across the world. But the very cool thing is, because of the fact that we've gone full circle, because of the patterns kind of following through all the way through the tech generations, applications and networking can move swiftly together pretty easily. And that's just made possible through technologies like Git, Kubernetes, containers, service meshes, and everything underneath as well. So to a network engineer, this is a technology we've needed forever. These sets of technologies, this nature of distributed, immutable, and ephemeral is something we've always needed. To a DevOps engineer, to DevOps practitioners, you've already solved this problem for us. But you've given us an opportunity, you've invited us to come and work on these systems with you, because quite honestly, you're not going to be able to get to all of this. You're not going to be able to handle the networking side at all times. Maybe you can, maybe you cannot. But offload this to your network engineer peers. Allow them to level up to the point that they can understand what goes on in a Kubernetes cluster. They can understand why you need 5 different clusters talking to each other. They can understand where a service mesh comes into play here. They can understand that they have a place here in the world of DevOps. So I keep doing that. I keep going back. So I left this slide blank because I have a few more thoughts to share in that. When it comes to your path, right, if you are a network engineer today, how do you get started? Where do you want to go? For me, how it started, right, I actually was in a situation where I was caught red-handed not knowing what Kubernetes was. I went out to Ottawa to work with a customer probably about 3-4 years ago, 2018? Yeah, 2018, so 4 years ago. And at the time, I was there to deploy a software-defined networking solution that required the usage of Kubernetes as well. And I knew nothing about Kubernetes, but I figured, you know what, I'm going to look through the documentation and stumble my way through and hope for the best. And so I did that, and what ended up happening was, as we were starting to deploy Kubernetes the hard way, so to speak, I started to realize that I had a lot of gaps. I didn't understand Linux as well as I thought I did. Not only that, the customer started asking me questions about how the Kubernetes API communicates with this SDN solution. And I was like a deer caught in headlights. Like, I honestly had no idea. But I basically said, look, I don't completely comprehend the solution yet, but I can get the right folks on the phone, and I did. But that was an ignition for me to actually go really understand what Kubernetes was. And how I started was, I'm a certification junkie, so I dug into the CKA, the Certified Kubernetes Administrator. And what I really liked about that exam was it was very hands-on, but it also allowed you to understand that, you know what, compute is compute. Storage is storage, networking is networking. We're just using a different system to issue all of these resources as we need to. But as a network engineer, was looking at this system, I started to think, hey, it feels like Kubernetes was just built on top of networking and Linux, which, in my opinion, it kind of was. And because of that, it allowed me to really understand it a lot better. It allowed me to then understand how packets moved around within that system. It allowed me to understand how the actual system communicated amongst itself. And it allowed me to then create this story to say, if you are a network engineer, you can find your way in the world of DevOps, just like I did. And quite honestly, I'm actually kind of still waiting for Tim Hawken to reply back to me about the CKN, the Certified Kubernetes Networking exam, because I asked about that probably 2 years ago, and I still haven't had a response. But the reason why I hope that we could have something like that, because it allows network engineers to also employ their existing skill sets in this world, right? If there was a Certified Kubernetes Networking Administrator exam, you know, what would I cover in that? Container networking interfaces, network namespaces, service meshes, pod networking, services networking, load balancers, proxies, API gateways. These are all network technologies anyways, right? Why not create something for them, create that space for them? And so my hope is that if Tim is watching, let's go do it. So that being said, I just want to end with the fact that if you are looking to understand networking better, there are a few resources that I highly recommend you check out. There's a Networking in Kubernetes book that allows you to transform your networking mindset to understand the world of containers, microservices, and even how this all interacts in Kubernetes. Kunal created an awesome, not even Kubernetes, this is just computer networking, like the basics. If you don't know networking, he's on YouTube. Go take a look at what he's got to offer. If you are far along your journey in networking, if you're trying to get to that space where you're already running Kubernetes clusters and you really want to, take your networking game to the next level, check out the Istio in Action book. That's going to give you some insights as to why you would want to use a service mesh, because quite honestly, it's a networking layer we've always needed, we've always desired. It just was created in different parts. I would do certificates and security with a system that sits externally that I have to manage myself. I would set up VPN tunnels between all my endpoints, between all my services. If I didn't have service mesh, I'd have to do this manually, right? But then not only that, like to route to all these services, what am I doing? I have to use maybe an ingress controller or maybe the gateway API spec or something along those lines. And that creates more complexity. And so the other piece, though, is observability. How do I see things? Now, that book is a great book. I'm sorry for the plug, but it's actually written by my CTO, and he's got some really great content in there. But what I ultimately want to say to y'all is if you're in networking, you have a place here in the world of DevOps. If you are in DevOps and you want to understand networking, here's where you start. Thank you, and always follow the packets.